Okay. The components of the air conditioning. In the last class we have seen compressor and then condenser, then the expansion valves also. And we have seen the orifice meter in the yesterday's class. So now the next one is the thermostatic expansion valve. The thermostatic expansion's job is to regulate the flow of a refrigerant so that any liquid refrigerant emitted through it has time to evaporate or change states from liquid to gas before leaving the evaporator. Actually, the function of the thermostat is to regulate the flow. So when we need the, I think you know what is the refrigeration part, what are the main components of the refrigeration is the same. What is the function of the evaporator is, expansion valve is, it is suppose we need some 21 degrees centigrade temperature in the room, but suddenly some number of occupants are increases, so that we have to maintain same 21 degrees dBT in the room. What happened because the number of occupants, the load is increased inside. Like if your refrigerator is there, we are keeping the products inside, maybe 10 kg, maybe like meat or maybe vegetables or maybe any other domestic whatever region. Suppose suddenly the quantity is increased inside from 10 kg to 15 kg, but you have to maintain same temperature. What happened? The evaporator has cooled all the remaining, which is earlier it is cooling. For that, the flow of refrigerant is more, need more. That's why the thermostatic expansion valve will be adjusted according to the load whatever inside. Right? But here air conditioning also, if the occupancy load, maybe inside load maybe increases, and it will be adjusted according to the load. That is the function of the expansion valve. Right? That's why the thermostatic expansion valve's job is to regulate the flow. It is simply called the flow regulator, or sometimes it is also called solenoidal valve. Solenoidal valve is a valve to control the flow. Suppose suddenly if you want to decrease the flow, means suppose the load is decreased, maybe it is the capacity of this room is 150, maybe it is something work is going on, suddenly the 50 members are maybe gone, and the load has to reduce. The flow is how to control, and with the help of this expansion valve, automatically it senses the temperature at the outlet of the evaporator, so that it will give the senses to the expansion valve, then automatically the flow will be controlled. If the load is increased also, the outlet temperature of the evaporator is increases. Right? That's why that signal is sent to the expansion valve, accordingly it will be open. Suppose in your England, suppose you are going on a bike, maybe suddenly your friends maybe ask some lift to drop somewhere. What happened? The fuel consumes more. We have to maintain the same speed, maybe 60 kilometers per hour, but suddenly your load is increased like your friend, but you have to maintain. But the fuel consumes more, depends on the load, your flow control is there. That is called the governor in our AC engines. The governor function is to control the flow in the AC engine. Here, the thermostatic expansion valve is also same. Why this is thermostatic means thermal. The temperature of the outlet temperature of the evaporator, it senses to temperature and then it gives the signal to the expansion valve. The next. This is the thermostatic expansion valve. Here, this one is the thermostatic expansion valve. This is your evaporator. Already, it is like condenser. See, this is the evaporator coil. This is the suction to the compressor. Suction line to the compressor. Then this is a small amount of load, a liquid refrigerant it is, And this is the small bulb it is there. It is a bulb, a sensor bulb it is. The outlet, this is the outlet and this is the inlet of the evaporator, right? So this is the thermostatic expansion valve where the liquid refrigerant from the receiver. Receiver means after condenser, there will be a receiver is there. We will see what is the receiver in the next slides. So this is the liquid refrigerants enter into the thermostatic expansion valve or a flow control valve it is, or it is a solenoidal valve. Then it will be moving into the condenser evaporator where the condensed under the refrigerant is low temperature, low pressure vapor, right? So this will be entered here between the evaporator, last point of the liquid stays here, right? Then it will be converting to gas. So this is the low temperature, low pressure vapor. It takes the load into the room or maybe if it is a refrigerator, then in the refrigerator. Then this temperature, it will sense the bulb here. It will flow like this. Then this bulb will sense the temperature, then send the signals to this valve. And there is the spring is there here. If the load is more inside, suppose, then what happened? The temperature may be sensed this, then pushes the spring down. Are you visible this here? Then, so that the area of the, there is a diaphragm something here. See, this is a line. There will be a, like a valve, piston valve something. Right? It is visible now? See, this is the valve. So, if the valve will be coming down, so that what happened? The area here may be increased if the valve is coming down. So that the more amount of fuel will be entered into that. Then it will be going to the evaporator. Then again it is the temperature suddenly decreases in the room, even though the temperature may be, it sends me and then it will give the signals so that if it is no need to more amount of the gas may be sent, then automatically will be, because of the spring action, it will be going up. If it is going up, there is a valve seat here. This valve may be, if it is going up, so that the area is decreased. It is visible or not? So like this way, the flow may be controlled. Right? That's called thermostatic expansion valve. Next. Then the automatic expansion also same. And this figure again is shown, same detailing. This is the adjusting screw. It is spring, whatever you have seen in the previous diagram. And then this is the bellows of the diaphragm. Then this is the lid seat. And then the refrigerant is in here. Then the strainer, the function of the strainer is maybe the same dust particle, maybe it is filtered here. Then it will be entered here. When the load is increases, then automatically it will be pushed down. So that the way this part may be increased, the area is increased, then it will be going to the evaporator. Right? If the load is decreased, automatically the spring will be up, the valve will be, it will be lifted up, then the area will be decreased, so that the flow may be decreased. Next. It is also same. These are also same function. Next slide. Yeah. Then another type of the flow control, that is the valve, is capillary tube. Fixed restrictions type device it is. Simple and low moving parts, low cost, pressure drop, developed due to friction and acceleration. Right? This is called the capillary tube. I think we can see in our refrigerator in the back side. It is located after condenser, right? And after expansion valve again. So this is, say it is expansion valve, then into the tubes are there. The diameter of the tube is very, maybe 1 mm or something like that, below 1 mm. So this will be, because of the friction and acceleration, the temperature increases. Finally, in the evaporator, form should be in the water form, but the temperature is very low, right? That's why this capillary tube we are using. Maybe most of the domestic refrigerators, if you see, if it is a open type, condenser type, then you can see this. The coil with the copper tubes are there. Next slide. Then next, the evaporator. The evaporator's primary function is to remove heat from within the cabin. It is also used for dehumidification. It is usually located within the control space. Right? Suppose you see this is the outside, inner side, there may be evaporator coils may be there. Right? So the function of the evaporator is to remove the heat, whatever the heat from the human being, or maybe any cold storage if it is there. There may be so many products maybe we have to preserve in that, food preserving processes. So that the evaporator function to remove the heat from within the cabin. It is also used for dehumidification. Then it is located in the control space, right? Within control space. Next. Okay. Next step. A blower motor circulates air from the cabin through the evaporator coil. So this evaporator is if you are a domestic refrigerator, it is called, we can say it is a deep freeze. But actually the total cabin is the evaporator. Right? But we call it as a deep freezer. Next slide. As the warmer air travels through the cooler fins of the evaporator, the moisture in the air condenses on the surfaces. Next slide. In order to keep the evaporator from freezing, several different temperature or pressure regulating devices may be used. This is suppose the cooling is over. Suppose you are not using the automatic thermostatic expansion valve. Maybe suddenly the inside load is decreases, maybe the occupants are maybe decreases. We need 21 degrees centigrade maybe for 100 persons, and suddenly some 50% maybe gone. But you have to decrease the load. If it is automatic, like your expansion valve is there, the temperature will be senses and then send the signal to the expansion valve. If it is not there, then what happens? Some amount of ice is forming on the tubes. Maybe your domestic refrigerator, if you open your deep freeze, it is forming totally ice on that. Right? Maybe if there is no products inside the freezer, it will be forming ice. Maybe ice cubes, maybe there are some ice trays maybe there. Like that, if the load is very low, if it is not automatic, then there may be forming the ice on the other tubes. It will be up to some condenser tubes also it will form. That is called frosting. Right? That process is called the forming of ice, like a snow on other tubes. That is called the frosting. And in order to keep the evaporator from freezing, several different temperature or pressure regulating devices may be used. Then what will be generally, if it is the more the cooling is, maybe the ice is formed on that, what happens after some time there is a chance to, what is the disadvantage if the way the ice is formed, there is a frosting. What is the disadvantage? Maybe inside the tube flow may be freeze. There is no question of the flow in the tubes. Maybe the refrigerant may be chance to freeze also. It becomes ice. Then if it becomes ice, there is no movement. But totally the system is failure. That's why suddenly what may happen if it is there, we will operate the some button, manual button, maybe thermostatic expansion valve, maybe it will be sensors. When you press the button, automatically the compressor will be tripped. After some time what happened, the compressor is not working, so that the outside temperature is more, it slowly try to melt. The ice is try to melt, then maybe if it reaches the original temperature, again the temperature may be on again. The melting process is called the defrosting. Frosting and defrosting. Next slide. Keeping the evaporator from freezing is extremely important because the frozen evaporator will not absorb very much heat. This is the disadvantage. Right? Next. This is the evaporator, and this is your expansion valve, what you have seen in the previous figure. And this expansion valve, it is some coils like, and this is the thermostatic switch it is. It sends the temperature. There is the sensor is there, there is the temperature thermocouple. It sends the temperature, and then it will give the again connection to the expansion valve. This side, that it sends the temperature and give the signal to the again to this, so that it will be automatic expansion valve. Next. This is the evaporator coils. Maybe if it is a split air conditioning system, maybe if you see, maybe it is installed on the wall. If you open the door, this type of these tubes are called evaporator tubes. You can see this. This is the AC machine actually. That's why within the conditioning space these are located, right? And the condenser and the compressor may be outside the conditioning space always. And you will see this type of types of air conditioning like window air conditioning or unitary air conditioning, or maybe split air conditioning and then centralized air conditioning. How this will work, we will see further. Next slide. So this is also same evaporator. See, this is the expansion device. It is a refrigerator coming from the condenser. Then here the blue line, maybe some any liquid. Then slowly it will be converted into gas. Then this is the sensor. Same previously you have seen this type of figure. This maybe sends the temperature, the outlet temperature of the evaporator. After taking the heat from the products, definitely the temperature of the before entering to the, suppose here there is a before entering the temperature, suppose T1. After then it is T2. T2 definitely more than T1. The temperature of the outlet of evaporator is more than the inlet temperature of the evaporator. That's why it sends the temperature and then gives signals to the expansion valve, so that the evaporator needs more amount of flow, automatically the expansion valve will. Next. These are the inside in the domestic refrigerator. You can see this type of something like cabin inside, right? So these are the tubes actually, right? Something like this. See here, it is connected. One side is connected to the condenser. Second one is connected to the compressor. These are the two ends. See, these are two different lines. This is one, and this is again ending. Okay, and these are the same. Maybe it is bottom of this cabin. It is not visible. Next. A refrigerant enters the evaporator as a low pressure liquid. The refrigerant temperature is lower than that of the air inside the cabin, and heat flows from a warm substance to cooler air. Definitely, the temperature inside the cabin, the temperature is lower than that of the air inside the cabin. Right? Meaning the temperature, this is the cabin, say it is a cabin, the temperature may be T1. The temperature at the evaporator is very low, lower than this temperature. Right? That's the meaning. Next. The warm air from the cabin passes through the evaporator fins and causes the liquid in the evaporator to be boil. Right? Next. The boiling refrigerant absorbs a large quantity of heat from the cabin. This heat is then carried off with the refrigerant to the outside of the, I think it is a maybe cabin, vehicle means cabin here. Next. The force that draws this low pressure refrigerant through the evaporator is the suction effect of the compressor. Because after evaporator, the connection is to the compressor. What is the function of the compressor? It sucks the refrigerant from the evaporator and then compresses to the condenser. During the sucking, the force, that means draws, right? This low pressure refrigerant through the evaporator when the suction stroke in the compressor. Next. Then next one, the receiver or dryer, receiver dryer simply. This receiver dryer is used in air conditioning system with a thermostatic expansion valve. It is used to store a refrigerant and separate any gas refrigerant from the liquid refrigerant. It is a cylindrical metal container usually located on the bulkhead. Next slide. The thermostatic expansion valve requires liquid refrigerant to operate efficiently. It is like a dryer. This is a thermostatic expansion requires the liquid refrigerant. Right? But if any gas, like any vapor is there, then this receiver dryer, that's why it is called dryer, it will be absorbed and then only liquid will be sent to the thermostatic expansion valve. The receiver and then different type are chosen for the type of the system and different need within the system. Next. This is the receiver dryer, the shape. Next slide. This is also same here. See, this is the refrigerant is receiver tube it is, then receiver body. So then here there is a filter here, then descent, dryer it is, and then it will be going out. So this is the dryer, then it is any gas particle is there, then in the refrigerant it will be removed. Next slide. Then the accumulator, it is also like a dryer, but the dryer is installed before the evaporator, and the accumulator is used in the system that employ a fixed orifice tube to control the flow of refrigerant into the evaporator. The accumulator prevents liquid refrigerant from reaching the compressor. Right? Before going to the compressor, if any liquid is there, then it will be accumulate. Next slide. It is plumbed into the system between the exit of the evaporator and the inlet of the compressor. So the dryer is installed between the condenser and the evaporator. Here you have to send only liquid refrigerant. Right? Any gas is there, then here it will be dried. And in case of the accumulator, you have to send only vapor into the compressor. Right? The function of the always any compressor, only the form only the gas. If it is a pump is there, suppose, then it will always should be in the form liquid only. So this is installed between the exit of the evaporator and the inlet of the compressor. It will also contain a descent that removes debris and moisture from the passing refrigerant. So if any refrigerant, if any liquid any moisture content is there inside, it will be absorbed. Only the vapor is sent into the compressor. Next. So this is the accumulator figure. From the evaporator it is moving like this, and then finally it is coming out to the compressor in the form of a vapor. Anything, any moisture content is there, it will be absorbed. This is the streamer. If any in the refrigerant with any dust particle is there, it will be cleaned. Through the streamer it will be moving always. Next slide. Then next one is the leak detectors. Suppose your refrigerator is not getting that much cooling, or maybe your air conditioning room is not that much cooling. So what is the immediately you have to observe that something, and there is something not working. The major generally the problem is, if the cooling is not sufficient, means generally the refrigerant may be somewhere it's leaking. Maybe we can't see where it is leaking, it is not possible visibly. Generally the complaint, suppose the refrigerant is not working, we will see all this open and we will close, and but we can't find any problem. Right? That's why there will be a chance to leakage the refrigerant during this flow. Maybe so many joints are there, because the compressor to condenser, maybe one joint is there, and from the condenser to the dryer, a joint is there. From the dryer to the expansion valve, maybe joint. From the expansion valve to the evaporator joint, and then evaporator to again compressor, or maybe accumulator, there is a joint again. So maybe so many joints are there. In between, anywhere, there is a chance to leakage because of this pressure. Right? Maybe that's why we have to use the leak detectors. The purpose of the leak detector is to determine the origin of the refrigerant leak. Special tools are required to find the refrigerant leaks, because the gas will escape, leaving no visible trace as to where it is excited in the system. Then visibly we can't see, because the gas it is, where it is leaking, maybe it is not possible. Suppose if your LPG gas, maybe it is leaking, maybe you can find with the smell. Maybe it will come smell, means maybe somewhere it is leaking. But in case of the refrigerant, maybe there is no smell. Next slide. This is the leak, one type of leak detector, flame type leak detector used to identify the refrigerant leaks. See here a detector unit. This is a burner. This is the search hole, hose. This is the valve. Then this is the cylinder. So maybe if you if you use one part, maybe it will be done. This is one type of the leak detecting. Next slide. Many different leak detectors are available to find the refrigerant leaks. Electronic leak detectors are extremely sensitive. Next one. These units are capable, these means electronic detectors are capable to detect the leaks. Electronic leak detectors are called halogens leak detectors and may be used to test for refrigerant leaks within HFC, that is halofluorocarbons, that is 134A. This is the name of the refrigerant. Generally, we are using for the domestic purpose. The refrigerant is 134A. It is a mixing of two refrigerants. It is called the azeotropes. Maybe you have studied refrigeration. Azeotropes, that is, there are primary refrigerants and the secondary refrigerants. So these are the refrigerants, a combination of two refrigerants. 134A is a blend of two. That's why halofluorocarbon. Next one. This is the electronic leak detector. It will give the something, a signal, like your maybe detectors. Maybe in the panel board, if you put some parts like that on the tubes, maybe due to any leakage there, then it will give the signals on the panel board. Next. Another style of leak detector as fluorescent dye. The dye is injected into the system, mixing with the refrigerant and oil, and is circulated throughout the system by the compressor. Generally, in the refrigerator, the compressor work is to compress the refrigerant. Because of some moving parts in the compressor, like we have seen earlier, like it is a piston cylinder arrangement, some connecting rod is there. So there are some moving parts inside. We have to use some lubricating oil to avoid the friction and to avoid some amount of heat. During that process, maybe there is a chance to mix the oil into the refrigerant. Right? That's why mixes with the refrigerant and oil. This oil is called lubricating oil to reduce the friction inside. Generally in the IC engines we are using lubricants to avoid some amount of friction. We can't avoid 100%. So this dye is injected into the system, mixes with the refrigerant and oil, and is circulated like regular. Next. When the refrigerant leaks, it pushes out some compressor oil and some of the dye. Through any leakage, maybe small damage hole or something, through that maybe it will be come out. Next, an ultraviolet lamp is used to cause the dye to fluoresce and indicate the source of the leak. Next slide. See, here there is a ultraviolet rays like a torch. So if you flash on that, because of that injected dye, whatever there, generally that it is leaking out. So that if you touch on that, maybe it will be give some other any color. That means this is the leakage source. Like that way also we can detect the leakage. Next. One other way of finding the refrigerant leaks into the result for them with an ultrasonic tester. Ultrasonic testers are able to detect sounds in the ultrasonic frequency that cannot be heard by the human ear. So you can't listen. Next. The detector then converts and amplifies the sound so that the technician can hear it using headset. Some detectors will also display the sound and lead. Like your mic may be there, maybe while you are working on the system, maybe you use something, headphones, right? If you light on that and it will be connected, maybe some small sound maybe you can find. That is a amplifying. What is amplifier? I think in the electronics maybe you have studied. What is amplification? The meaning of amplification is enlarge. While you are using the mic sets or speakers, I am talking maybe general talking, but the sound is coming very high. That is converter, that is called amplifying. It will be enlarged sound. Right? Like that here, maybe a small sound, without amplifier you can't listen. Then that's why we are using for this type of detectors. Next slide. This is the headphones, and maybe you can flash this somewhere, so that through this may be amplifier, it converts the sound. So this is the one way of a leak detector. Next slide. Then coming to thermometers. I have a thermostat. A thermometer is used by a technician to measure temperatures throughout the air conditioning system. The temperature range of the thermometer should be between 18 degrees centigrade to 104 degrees centigrade. Before that leak detector, there is one more way is the soap detection also is there. Maybe if you use the soap water, if you use the soap water, if anything leakage is there, a small bubble may be coming out. That is one way of the soap testing, it is called. I am not including here. General, it is a very, very simple technique to find out the leakage of the thermometer. అక్కడ ఉంది. ఇంకా నెక్స్ట్ ఇంకా అదంతా అయిపోవాలి. యా ఇక్కడే ఎస్. Thermometer is used by the technician to measure the temperature throughout the air conditioning system. The temperature range of thermometer should be between minus 18 degrees centigrade and 104 degrees centigrade. Next. When accuracy is the main concern and electronic thermometer may be required. Infrared temperature guns are used to measure radiator temperatures, coolant lines and engine operating temperatures. Infrared thermometers, if any temperature is there, maybe there is no chance to put any thermocouples on that. If you flash a light on that, then you send the temperature. That's the infrared temperature guns, it is called. Maybe it is there in our department also. You can see the temperature of maybe any surface. Possible to locate any thermometer there. So you just touch light and then the temperature maybe you can see. Next slide. So this is the thermometer are used to make accurate diagnosis of air conditioning system. This is the 245 some temperature showing. You just do the touch, then it will be the temperature. Next slide. When the vacuum pump, next one is used to remove moisture and air from a system that has been opened for a service or when leak has been repaired in it. This is if any compressor, maybe some repair is there, definitely, generally the compressor, if it is any repair is there, definitely have to load the again refrigerant inside, because you have to disassemble the compressor, then again you have to inject the refrigerant. During that process, maybe any air may be entered in there. That's why you have to clean the tail, you have to remove the air inside. That is called a vacuum pump. Maybe in your condenser unit in thermal engineering 2, something when it is condenser function is, it condenses, right, and they do the temperature. During the process the vacuum is created, then maybe there will be a pump using to avoid the vacuum. Here also, if any repairs maybe occur, then this type of vacuum pump are using. Removing air and moisture that has entered the air conditioning system is called the evacuation, it is called. Right? It is called evacuation. You have to remove the air or maybe any moisture inside. That process is called the evacuation. Next slide. If left in the system, air will cause higher than normal pressure and carbonization of the compressor oil. If moisture is left in the system, it will mix with oil, causing acids to form in the system. That means if air remains in that, maybe these are a problem how to face. Because in the air means maybe nitrogen and then some gases are there, right? If these are maybe mixing with that and it will be carbonization, and then it may be something reaction, chemical reactions may be found. That's why definitely you have to remove the air from the systems. Next slide. It is like on the fan the air is given forward direction, it may be reverse direction. only system, right? Like your exhaust fan, some. That shape is exhaust fan, right? Next slide. Then, next is according to your syllabus, then human comfort. I think maybe you are comfortably sitting here. Maybe I don't know my lecture, you are comfortable listening or not. Right? So, how can you say human comfort? Next slide. Human comfort is that condition of mind which expresses satisfaction with the thermal environment. Right? Suppose, generally, we are using the cool drinks, like or maybe ice creams. What is the purpose of why we are using that? After that, definitely we will feel satisfaction. Because the outside temperature is more and we need some cool water or maybe cool drink. Generally, we need the cool drink only for the mental satisfaction. That is the comfort. We feel comfort. Right? Without any comfort, maybe we can't do anything. That's why the comfort is very important. That's why the human comfort is that condition of mind which expresses satisfaction. Without satisfaction, maybe my job is waste. Right? As a teacher, my duty is to teach the students. When I teach good, then I will satisfy. Otherwise, maybe I am not satisfied. Maybe if you are not understanding, you are not satisfied. That's why the mind expression satisfaction is important. In case of the air conditioning also, there is a human comfort it plays major role. Next slide. Strictly speaking, the human comfort depends upon psychological and psychological conditions. If you are using a cool drink means, psychologically you feel, okay, satisfied. But with the cool drink, maybe it is not advisable also. Why it is not advisable? Generally, a simple example, the human being temperature is maybe 37 degrees centigrade or maybe Fahrenheit is 98 degrees Fahrenheit. If you convert into the degree centigrade, it may be 37 or 36 plus something. Right? 37 degrees centigrade, say, it is, we are talking about the degree centigrade. Can you tell me what is the temperature of the ice cream or maybe cool drink? Definitely, it is below 15 degrees centigrade, maybe above 10 degrees centigrade. If you are using the cool drink, it is 37 degrees and the 15 degrees, it's inside. Then automatically, if you use a very cool that liquid, definitely we feel thirst immediately, most of the time. Again, you have to use the water. Why it is? Because if you use a hot metal rod, suddenly if you dip into the water, what happens? Maybe some vibration you hear in the water, or maybe suddenly you can find some sound also. That means suddenly it's not possible. Like that, your body temperature and the whatever you using the consumes, the temperature is very difference. Lot of difference is that. These two will be fighting inside. For that, the system has to work more. That's why you feel thirst also again. Again you have to use water. That is, strictly speaking, human comfort is psychological feeling also. Okay, I use it, the cool drink, then okay. Or maybe you are feeling not well, maybe you are feeling some headache or something. Immediately, you will go to the doctor. Generally, doctor will